Okay, so let's go ahead and take a look at how we can name and write actual formulas using the shortcut so we can no longer draw the electron dot structures. Okay. So we'll learn the rules for naming and writing binary ionic compounds. Then we're also going to make sure we can do it with polyatomic ions. So we'll start off simple and then go into the more complicated ones. Then we'll prepare for your pre-lab. So a binary compound, if you think about it, what does it mean to be biannual, right? Or a bicycle means two, right? So a binary ionic compound is composed of two elements. They can be either ionic or molecular. We are going to focus on the ionic ones. We'll touch molecular after we come back from Thanksgiving. So like I said, specifically we'll look at binary ionic compounds, and this is going to use a monatomic cation and a monatomic nonmetal, an anion. So I'd like you to just review and talk to your partner. Why does it have to be a metal cation combining with a nonmetal anion? Go ahead and take a couple of seconds for this. Well, I'm hoping that you'll notice this happens because our opposites have to attract. If I have that metal, it has to attract to a nonmetal. If I have that cation, it's going to attract to the anion. So, there are two rules in naming a binary ionic compound. And go ahead and write this in on your note sheet. Oh, sorry about that. Let me undo that. Let me make this bigger for us so that way I can work on this. Okay, so if I undo that, okay. Sorry, so once again, there are two rules. The first one is we always name the cation first. So if it's barium, potassium, sodium, calcium, if it's anything in columns 1A to 3A, then I need to use the cation first, as well as with transition metals. Second part is I need to use the anion next. And as a reminder, if I have an anion, I'm always going to stick an IDE at the end. Right? So, first step, cation, second step, anion. Third thing to remember is that you've changed it to an IDE. So let's go ahead and take a look at these, and I have CS2O. So what I want you to do is first find the CS, and then I want you to find this O, and let's write the correct term. That number is not as important right now. All I want to know is the name of this formula. So if you found CS, it is on the left-hand side of your periodic table, and CS stands for cesium. So I'm going to call this cesium. Since it's combined with a compound, as a compound, I find O, which is oxygen. But we've always said that we start with our cation and we end with our anion. And these need to be an IDE. So yes, O is oxygen, but if I follow the rules, that means I need to change it to oxide. So the name of this formula is cesium oxide. Alright, let's go ahead and find this cation of Na and this anion of Br. And by now you should hopefully remember that Na stands for sodium. So I'm just going to call it sodium since it's a cation, so I just use its normal name. But I do have to change my bromine into bromide. And that's how you name our binary ionic compounds. Okay. Great, so let's take a look at the next thing, and let's see. It says, what is the name of the following compound? Right? So go ahead and try to name this. find my Cu. From the other problem, we already know that O is oxide, so I'm going to call this oxide. Alright? Well, you're correct. This Cu is copper. Now here's the problem. Copper is what kind of metal? Copper is a transition metal. And if you recall from the previous video, transition metals can give away multiple numbers of ions. So I need to find out, well, how many electrons, excuse me, not ions, but how many electrons is copper giving away? So what we have to do is look on our ion sheet and take a look at the different coppers that exist. So I'm going to pull a few of them out, but there is a copper plus, there is a copper 2 plus, and I'm not quite sure if it's on your sheet, but there is also a possibility of a copper 3 plus. So if I take a look at this, a 1 plus is going to get rid of 1 electron, a 2 plus is going to get rid of 2 electrons. I'm going to need to make sure I know which one this is. So it says, what's the problem with this? I need to know which one we're using. So let's think about this, right? Oxygen is in 6A. If I'm in 6A, that means my charge is 6 minus 8 is negative 2, right? So I know this oxide has a negative 2 charge. I need this to be stable. So in order to create stability, if I have a negative 2, what kind of positive charge do I need to balance this out? And I hope you said I need a 2 plus to balance out this 2 negative. So what I should really call this compound is copper, and in parentheses 2 oxide. And that's the key thing with these transition metals, that typically you will have a parentheses with a Roman numeral to let me know how many electrons we're getting rid of. And so this takes practice, but that is one thing that we are going to take a look at. Alright, writing formulas for binary ionic compounds. Recall the net ionic charge of formulas must equal 0. So how can I create a net ionic charge of 0 for the following ions? If this is a 3 plus and this is a 2 negative, let's take a look at our common multiples. I need to find balance between these, right? So if I find balance between these, the only way to balance this is if I have the charges of 6, right? So in order to do this, I want this to become a plus 6, and I want this to become a minus 6. Well, isn't the only way to do that if I have this 2 times, right? A positive 3 times 2 is a positive 6. And the only way to do this is if I multiply by 3 times, right? So what we see is I'm going to need 2 Fe's, and I'm going to need 3 O's. And we could draw this with dot structures and everything, but we're going to take a look at how we can do this shortcut without having to worry about our math up here. What I do want to say is we have to name this compound. So I take a look. Fe is iron. So I know this is iron. If you notice, Fe is a transition metal. Since it's a transition metal, what do I have to do? Good. I have to give the number of electrons that are being given away. So if this is a 3 plus, what number should go in here? And I should have a 3, but it needs to be written in Roman numerals. Okay. And then I have oxygen, which if you look at your ion sheet, what's the name of O2 minus? Good. It's oxide. So this whole thing is not just iron oxide, but you have to call it iron 3 oxide. So let's take a look at this shortcut and see how we do this. Okay, I have a calcium 2 plus and a sulfur 2 minus. And remember, our key goal is to have a net charge. I'm going to say net charge equal to 0. So I take a look at these charges. I have a 2 plus and a 2 minus. What do you notice about that? Good, they already are neutral. A 2 plus is going to cancel out a 2 minus. So anytime my charges are the same, I know I can get rid of them and just combine this, and I get CaS. I don't have to worry about any subscripts. I know that one of these is going to cancel one of these. And the final step is to name this, and Ca is calcium. Sulfur, once it combines with something, if you look on your ion sheet, is now sulfide. Yep. Is now sulfide. Hold on, give me 1 minute. Sulfide, sorry about that. Alright, so let's take a look at K plus 3 minus. Okay, so if I take a look at this, I notice I have a 1 plus and a 3 minus. Does this give me a net charge of 0? No, but we can use our common multiple math, but there is a shortcut. What I can do, it's called the crisscross. I'm going to cross down the coefficient of this plus, which is a 1, and cross this one down here to see what I get. That's going to give me K3P1. I move this 3 down here. I move that 1 down here, but since it's a 1, it's an invisible one. And if I were to check this, if I had 3 Ks, wouldn't that give me 3 1 pluses? And if I have this 1 3 minus right here, a 3 plus, just to show our math, plus 3 with a minus 3 gives me that 0 charge that I need. So by using the crisscross method, I can actually find the correct numbers for a compound. And if I name this, K is potassium, and P is phosphorus, but if it's a P3 minus from your ion sheet, we find that that's phosphoride. Good. So now let's take a look at polyatomic ions. What do I do if these have more than 2 elements? And just to recall, what's the suffix that most polyatomic ions end in? Good, it's ITE or ATE. So let's go ahead and take a look at this right here. And so let's use our crisscross method. If I have these, and just to take note, that is a negative charge, but that number 3 is at the bottom. This charge of a 2 plus is going to swing down. Oops. This charge of a 2 plus is going to swing down here. This charge of a 1 minus is going to swing down here. So if I write this, I would get Ca1, then I would get NO3, 2. Now, if you take a look, there is a problem here. That's right, I have to bring this 2 down here, but now this doesn't look like NO3, 2. This looks like NO32. I need to make sure I make that distinction. So anytime I have polyatomic ions like this NO3, because there's different pieces, a N, a capital O, I need to make sure I put this in parentheses. So I'm going to put my NO3 in parentheses, and this now tells me I have 1 Ca and 2 of these NO3s, not 32 O's. Then if I name this, Ca2 plus is calcium, NO3 minus from here is nitrate. So this is calcium nitrate. Let's take a look at another problem. I have Li plus, CO3 2 minus. If I do the crisscross, there's an imaginary 1 here. So that's going to cross down here. This charge of 2 minus is going to cross down here. And if you notice, I'm canceling out that plus and the minus sign. I don't have to write them. This becomes Li2, and I have the CO3. And I need to bring down that 1. But if it's a 1, do I still need to bring it down? No, so I'm actually going to leave this, and I'm not going to need those parentheses. If I look at my ion sheet, you'll notice I have Li+, which is called lithium. And I also have CO3 2-, which is carbonate. If you notice, there goes our ATE part. This whole molecule is lithium carbonate. So we're going to use that crisscross method a lot to stabilize these compounds. All right, let's do another one right here. If I crisscross this 3+ is going to go down here, and this 2- is going to go down here. This is a monatomic ion, so I just have Al2, okay, and I get rid of that negative sign. I have CO3, and you notice I have to bring that 3 down. So what I'm going to do is put my CO3 in parentheses, and then bring this one down right here. And if I name this, this is aluminum, and it's carbonate again. So now you don't have to worry about creating a charge of 0. It will naturally create a 0 charge for you. So what I'd like you guys to do, this is due today, page 263, number 10, A through D. These ones right here are monatomic, and these ones right here are a mix of monatomic and mainly polyatomic ions. What I do want to show you before you begin is how you complete your pre-lab worksheet. So all of you will receive a worksheet that looks like this. So what I'd like to do is take a look at how you fill this out. And I want you to really compare it to Punnett squares. Remember in Miss Francisco's class, you would do big B, little b, big B, big B, and you would cross them, so this and this would make big B, this and this would make big B, little b, this and this would make big B, once again this would make big B, little b. Well, that's the same thing for our pre-lab worksheet, except you're using ions. So I have one already completed for you, Al parentheses OH3. It's aluminum, and this is hydroxide. So let's do one of these together. Let's take, I don't know, let's take this one and this one right here. If I look on my ion sheet, I find Al3+, and I notice its name is aluminum. Right? If I look at SiO3 2-, so let me go ahead and open up our ion sheet here. Come on, ion sheet. Mission, right here, chemistry. Where's my ion sheet? Maybe it's here. No, that's not it. Okay, give me 1 minute to just find the ion sheet. Ion sheet. Here it is. Okay, so if I open up my ion sheet, give it some time. We see that Al3+ is called aluminum, right? And then what we're going to want to do is we are going to want to find SiO3 2-, and if you see here, sorry, my page is slightly different from yours. The SiO3 2- is called silicate. So what I'm going to do now is in here I'm going to write the word silicate. And I'm going to write it on the top since I have more room. Well, according to our rules, doesn't the cation come before the anion? And in this case, this is where my cations are. So automatically, I know that this is going to be called, and I know I'm going to run out of space here, so I'm going to write pretty big. This is called aluminum silicate. Right? And now I need to cross this Al3 plus with this SiO3 2 minus. So if I need to, I'm going to write it up here, Al3 plus SiO3 2 minus. And I take a look, which one is polyatomic? The silicate is polyatomic, so one thing I need to take note of is I might need to use parentheses. So if I crisscross this, I'm going to bring that 3 down and bring this 2 down. And if I do this, I get Al2, and I don't need parentheses if that's monatomic. And this right here is polyatomic, so I'm going to put that in parentheses, SiO3, and bring this 3 down here. So now I have my chemical formula, and now I have my chemical name. And this is what we'll be doing for your guys' lab. You guys are going to create different compounds, and you're going to need to know how to name them. So I'd like you to fill out this chart. This chart is going to be due on Friday when I see you next. So go ahead and work together on this and use your book as a guide. Thank you, and I'll see you on Thursday. I'm sorry, I'll see you on Friday. Take care.